With the growing influence of the new energy vehicle, photovoltaic energy storage, and power drive industries, the quality requirements for winding components such as transformers, inductors, and motors have become more stringent. The automotive industry demands higher efficiency and lower losses from winding components, continuously improving their safety insulation performance to meet the requirements of EV energy storage. Despite the high test voltage of the insulation tester, its testing frequency is 50/60ths of a hertz. Applying it to both ends of the test coil, equivalent to a short circuit condition, cannot detect interlayer short circuit defects in the product. We need to use non-destructive pulse high voltage testing technology for graphical analysis to detect defects caused by interlayer short circuits and ensure the reliability of wound components. We need to use non-destructive pulse high voltage testing technology for graphical analysis to detect defects caused by interlayer short circuits and ensure the reliability of wound components. 7750 impulse winding tester features a measurement speed increase of up to 10 times per second. It utilizes non-destructive pulse voltage for waveform sampling and comparison, effectively detecting insulation issues in motors, transformers, BL inductors, and other components, and supports 6 waveform comparison modes to meet the electrical characteristics testing of various winding components. 200 MHz high impulse test sampling rate. The best choice for speeding up testing to up to 10 tests per second is automatic inductance testing. It rigorously monitors breakdown voltage testing to ensure insulation performance, which allows setting the start voltage, end voltage and minimum percentage of voltage rise from the start voltage. In the Laplacian amperison mode, it determines whether the measured values exceed the set standard value, validating the withstand voltage strength of the tested winding component. .7750 adds USB host access test data function. Add Laplacian comparison for more precise insulation performance testing of integrated molded inductors. During the manufacturing process of integrated molded inductors, there can be issues such as conductor or magnetic powder material overflow into unintended structures, causing interlayer short circuit. Or uneven electroplating of the conductor material can also result in abnormal conducting paths and interlayer short circuits. By employing the second-order differentiation algorithm, effectively detecting quality issues related to electrical leakage caused by poor solder joints in the monolithic inductor,